Finding the general term of a sequence. So these are the good questions. So I do hope after watching this video, you will be able to answer the following questions. First, we have, how do we find the general term of a sequence if the second difference is constant? Next, how do we prepare a table for a sequence? Next, how do we get the first difference? And how do we get the second difference? Lastly, how do we determine what general form are we going to use? Okay, so let us have our simple drill first. So I'd like you to complete the sequence. So we have 1, 3, 6, 10. What do you think will be the next 3 terms of this sequence? Okay, so our next 3 terms for this sequence is we have 15, 21, and 28. Okay, so observing more our pattern a while ago, so we have 1, 3, 6, 10, 15, 21, and 28. As you can see, getting the difference, we do have 2, 3, 4, 5, 6, 7. The first differences are not the same. But if we're going to get the difference again of the first differences, so we'll have same difference already. And actually, this is what we called our second difference. And a while ago, the 2, 3, 4, 5, 6, 7, this is termed as the first difference. So now, if this is the case, so that means we can now get the general term of this sequence using different steps compared to what we did in our general term for sequences which have common or constant first difference. So that is our target for this video. I hope everybody can determine the general term of a sequence whose second difference is constant. So as you can see, in our example a while ago, the second difference is constant. So these are the steps to find the general term or the nth term if the second difference is constant. So same with what we did there in our previous video. So prepare a table as well with row headings n and a sub n. Next would be get the first and the second difference. Take note, if the second difference is constant, then form 3 equations by using 3 pairs of numbers from the table. And the general form that you are supposed to follow in forming the 3 equations would be an squared plus bn plus c equals a sub n. And if you're done forming the 3 equations, you can now solve for the values of a, b, and c. And of course, if you do have the values of a, b, and c already, you may now substitute that values in the general form again and simplify if necessary and then checking. Okay, so let's start. Let's have our first example. Find the general term of the sequence 1, 3, 6, 10, 15, 21, 28. So I'll be using the sequence as well that we use in our drill. So for example, I asked you to find the 100th term of this sequence. So better if you do have the general term so that it is easier for you to find the 100th term or whatever term I'm going to ask. So let's start. First is prepare a table. So as you can see, we do have same entries for our n, so consecutive positive integers, so 1 2 3 4 5, and for a sub n, so this will be based on the sequence that I've given you a while ago, so it's 1 3 6 10 15, and let us just get first 5 terms of the given sequence. Okay, so for step 2 in our drill, we've taken already the first difference and second difference, so we can now see that the second difference is constant, so therefore we are supposed to form 3 equations, and that will be our step 3. So therefore remember that to form 3 equations, just make use of the table that you prepared as well. So we have first pair, then will be your second pair, and third pair. So others might be asking, why is it that I used this 3 pairs instead of using 4 and 10, 5 and 15? So again, my explanation to that is so that the number is lower and you can easily do the mental computation on basic operations easily, rather than using a more complicated or higher numbers. So I usually use the least numbers or the least pairs. Set. So now let's start forming the 3 equations. So basically we need to pattern it with our general formula, an squared plus bn plus c equals a sub n. So for our first equation, so equation 1, so just simply substitute the value of n and a sub n in our general formula, and then simplify. 1 squared times a, it's 1, and then b times 1, it's b, and copy the rest of the terms, the c and then 1. Okay, for equation 2, same process, but we are going to look at the second pair. So substituting n equals 2 and a sub n equals 3, and then simplify. 2 squared, it's 4, 4 times a, it's 4a, then 2 times b, it's 2b, and copy the remaining terms. And lastly, for equation 3, of course, the third pair. So this will give us the equation 3. So substituting the value of n as well as a sub n. So we have here 3 squared, it's 9. 9 times a, it's 9a. 3 times b, it's 3b. And copy the rest of the terms. Okay, so we are now done forming the 3 equations. That means we can now proceed with finding the values of each variables. So to solve for a, b, and c, so same process, we are supposed to use elimination method. Or if you want to use substitution, then it's your choice, but my recommendation, better to use this elimination method. So here we need to pair first equation 1 and equation 2. So as you can see, we cannot eliminate yet one of the terms there because we don't have additive inverses of terms there. So we need to look for factor or factors, but this time I'll be using -1 as factor, wherein I will multiply it with equation 1 so that I can have a additive inverse of one of the terms there. Okay, so multiply -1 to equation 1 to each terms of equation 1, so we will end up with -a minus b minus c equals -1. So I will consider it as equation 4 already, so that you will be guided of the equations that we are using. And paired with the second equation. So now, as you can see, we can now eliminate negative c and positive c, because if we're going to combine that will become 0. So therefore, combining like terms, the remaining like terms, we have negative a plus 4a, so 3a. Negative b plus 2b, it's positive b. And again, the term with variable c, we are going to eliminate that already. And for constant, we have positive 2. Negative 1 plus 3, so it's positive 2. Okay, so that means we have our answer 3a plus b equals 2. It's a combination of equation 1 and equation 2. So for now, I will name it as equation A again, so that you will be guided of our answer. Next we need to process is equation 4. We are supposed to pair it with equation 3. So the equation 4 that we get a while ago, we will be pairing it with equation 3. So as you can see, we can eliminate now the variable c here, because as you can see, we have our additive inverse. It's negative 1c and positive 1c. So we can now continue simplifying this. So negative a combined with 9a will have 8a. Negative b combined with positive 3b will have 2b. And c, terms with c will be eliminated already, and negative 1 plus 6 will have positive 5. And for this time, we will be naming this answer as equation b. Okay, therefore, we do have two equations already. We got this from equation A, from combination of equation 1 and 2. And then equation B, it's a combination of equation 3 and 4. Okay, so now, to continue the process, we need to combine as well our answers in equation A and equation B. So to start getting the values, so here we cannot eliminate yet one of its terms because we don't have additive inverse again. So I will look for a factor, and that is negative 2. I will be multiplying negative 2 to equation A, and so that I will have additive inverse. So we will just simply copy equation B. So here, as you can see, multiplying negative 2 to both sides of equation A, so I will end up with negative 6a minus 2b equals negative 4, and simply copy equation B. And then combining like terms and eliminating those additive inverse terms. So negative 6a combined with 8a, so we will have 2a. So again, negative 2b and positive 2b are eliminated already. So constant negative 4 plus b equals 1. I mean negative 4 plus 5 equals 1. So this is not yet the final answer. We are supposed to apply multiplication property of equality. So we'll just do the shortcut, divide both sides by 2. So 2a divided by 2, it will be a, and then a equals 1/2. So we do have our value already for the variable a. Now let's proceed with getting the value of the other terms. Since we do have the value for a already, so we just substitute the value of a, which is 1/2, to the equation, and it's either equation A or B, to get the value of the next variable. So our equation A a while ago is 3a plus b equals 2. That is what I'm going to use instead of equation B. Why? Because the numerical coefficients for equation A is somehow lower compared to equation B, so that we can easily do the basic operations. So substituting 1/2, so 3 times 1/2, it's 3/2 plus b equals 2, and then isolate the b by applying addition property of equality. But then I know you are particular with the concept of transpose. Okay, so we'll just transpose positive 3/2 to the right side, so that will become negative 3/2, and then simplifying it more, 2 minus 3/2 will have b equals 1/2. Okay, so we have our value for b already. So to get c, lastly, so we will just substitute both the values of a and b in our equation. So now, since we do have two values already, and we are supposed to get the remaining variable out of those three, so we may now use the original equations that we had, the equation 1, 2, and 3. So it's your choice if which one are you going to use. But for me, my tip again, better to use the equation wherein the numerical coefficients are lower compared to the rest of the equations for you to easily do the basic operation. Okay, so I'm gonna use equation 1. So as you can see, a plus b plus c equals 1. So it's not that complex for us to do the process. So 1/2 plus 1/2 plus c equals 1. So I've substituted it already. And now let's combine 1/2 plus 1/2 because they are like terms, they are constant. So it's 1/2 plus 1/2, it's 1. And then as you can see, it's not yet final. We need to isolate the c. So to do that, apply addition property of equality, but you are more particular with the shortcut, and that is transpose. So we'll just transpose the sum of 1/2 and 1/2 to the right side to be combined with another constant. So 1 minus 1, 0. That means the value of c is 0. So we're done getting the values of the three variables. Now, we may now proceed with step 5, and that is simply substituting all the values that we've got to the general term. So again, our general term is an squared plus bn plus c equals a sub n. So a while ago, we got a equals 1/2, b equals 1/2, c equals 0. So substituting in the general form, we will have 1/2 n squared plus 1/2 n plus 0 equals a sub n. Now, as you can see in our equation now, we can disregard the c there because it is just 0. But looking at the numerical coefficients of our first term and second term, we can still simplify that because as you can see, they both have 2 as denominator. So that means we can rewrite this equation this way. N squared plus n all over 2 equals a sub n. Therefore, the general term for our sequence will be n squared plus n all over 2 or over 2 equals a sub n. Okay, for checking, let us just use the general formula that we've got, then to check if it corresponds to each terms of the given sequence. So let's check equation. Let's check the first term, I mean. So n squared plus n divided by 2 equals a sub n. That's what we got a while ago, the general form. The general term. So substituting 1 to check the first term. So 1 squared plus 1 all over 2. So we'll have 1 plus 1, it's 2. 2 over 2, it's 1. So it's correct. Our first term in our sequence is 1 a while ago. And for the second term, same process. Let's just substitute 2 by now because we're supposed to check second term. So substituting 2. So that's it. A sub 2 equals 3. Okay, and next, how about term 3? So, of course, we're supposed to substitute 3 because we are going to check the third term. So, substituting 3, so 9 plus 3, it's 12. Then 12 divided by 2, it's 6. So, that means our general term, the general formula that we got, the general term that we got is correct. Okay, so now let's proceed with our second example. Find the general term of this sequence. So 5, 8, 15, 26, 41, and so on. So our process will be starting from this table. So we have here our table already, and for step 2, we need to check if it is a quadratic sequence as well. So by looking at the second difference, if it is constant, so first difference, so we have 3, 7, 11, 15. The first difference is not the same, therefore we cannot check the second difference. Okay, so we do have constant second difference, therefore it is a quadratic sequence, and with that we are supposed to form 3 equations already. Okay, so for our equation 1, a plus b plus c equals 5. And for equation 2, we have 4a plus 2b plus c equals 8. And lastly, 9a plus 3b plus c equals 15. Now, since we do have our 3 equations, we can now get the values of a, b, and c one by one. Okay, so for our step 4, so I'll just give you the value already of each variable. So for variable a, we got a equals 2, and then for b, we have negative 3, and for c, we have 6. Since we do have here our values for the 3 variables, we can now proceed to step 5. And for our step 5, simply substitute the values of a, b, and c in our general term. So our answer will be 2n squared minus 3n plus 6 equals a sub n. Okay, so for additional practice exercise, so I have here 2 sequences for you to work on. So the first sequence is intended for the boys to answer this, and for the second sequence, this is intended for the girls. But of course, if you want, you may answer everything. Okay, so you may pause this video first because next slide will be the final answer already. So here's our answer key for the 2 questions that I provided, additional questions. So for the boys, the first question intended for the boys, the answer is n squared plus 1. And for the girls, we have 3n squared minus 2 all over 2 equals a sub n. So that's it. So thank you so much for watching this video. I hope you learned about getting or finding the general term of a sequence with constant second difference, or also known as quadratic sequence. So thank you for watching. I hope you subscribe now.